Okay, in section 6.3 we're going to be talking about the definite integral and the area under a graph and how the two are related. So first I just want to introduce you to the area under a graph. For example, something that looks like this. And hopefully, I don't know if you've ever seen something like this before, but I don't know if you've ever wondered how you could find the area under this curve here. So you see, like in algebra, you've always just been working with rigid structures that you could find the areas using your geometry. Well, this is now a curve. So that's one of the cool things about calculus, is that we're going to be able to use calculus to find areas under abnormally shaped objects. And all the area under the curve is the integral. So if you take the integral of the function that creates this curve, then that will give you the area under the curve, which can be very useful on in many applications. So if you're asked to find the area under a curve, then all you do is you're obviously going to have to set two parameters, a and b, to give you an actual definite shape here. And you're just going to find the integral from a to b, those are your defining factors of the integral, of f of b minus f of a, the integral of, the point where b meets the function minus the point where a meets the function. So, for example, on the prep quiz, if you see a problem like this that asks you to draw the region whose area is given by the definite integral, do you see that in this particular case we've got the definite integral from 3 to 6 of x squared plus 1. So the function x squared plus 1 looks like this, like each one of these curves. And so the area under the curve from 3 to 6 is obviously going to be, which one? This one? Yeah. Here's 3, here's 6. So the area under the curve here is going to be the integral from 3 to 6 of x squared plus 1. Okay, so if you're actually asked to find the area under a curve and you're not given anything other than the function, you can easily do that. To find the area under the curve, we're going to take the integral. So we're going to say we're going to find the integral from 0 to 16 of x to the 1/2 plus 8 dx. So to find that integral, we're going to take, what is that going to be? 1 over 3/2 x to the 3/2 plus 8x is the integral. So if we simplify that integral, that's going to be 2/3 x to the 3/2 plus 8x. So that's our function, that's the integral. And now to find the area under the curve, we're going to have to find that between 0 and 16. So first, if we find f of 16, we're going to say 2/3 times 16 to the 3/2 plus 8 times 16. And we're going to get, that's going to be 128 over 3 plus 128, which is going to be 128 over 3 plus 384 over 3. So if we add those together, we end up with 512 over 3. So that's f of 16. Now let's find f of 0. And this is going to be obviously f of x. F of 0 is going to be 2/3 times 0 to the 3/2 plus 8 times 0, which is 0. So we're going to say 512 over 3 minus 0 gives us 512 over 3 units squared. And so that is the area under the curve square root of x plus 8 from x equals 0 to x equals 16. So I hope that makes sense, helps you work through the prep quiz, and I will see you on Wednesday.